Hello, I'm Graham Lewis, and in this short video we're going to look at long division of polynomials. I'm going to do it by looking at a numerical example alongside an algebraic example to show that they're exactly the same. So let's start with the 748 divided by 3. I would call the 3 here the divisor, and equally x plus 2 in the polynomial we would call the divisor. So let's start. So when I'm doing long division, we do 3 into 748. And if we're doing the algebraic one, we do x plus 2 into x cubed plus 3x squared minus 4x plus 1. Now, if we look at one important thing to notice, if we look at the actual columns here, we'll notice that we've got units, tens and hundreds, and all of the columns have to be represented. Equally in our polynomial division, you want to think of it the same way. We've got our constant column, the 1. We've got our x column, we've got our x squared column, and our x cubed column, and we need all of the columns represented. Okay, so let's go ahead and start looking at these two. So if I start on the left, the first thing I do is 3 into 7. 3 into 7 goes twice, and it has a remainder. We know it has a remainder of 1. In long division, what we do is 2 times 3 is 6 and subtract to find the remainder. So in long division, we have to actually show the 2 times 3 to get the 6, subtract it from the 7 to get the remainder of 1. In other words, 3 goes into 7 twice and the remainder is 1. Let's do the same on the right hand side with algebra. It's identical. So you take the highest degree here, x, and just like we did, how many times does 3 go into 7? We consider 7 divided by 3, and we know it goes into 2, and the remainder is 1. Remainder 1. And we do x cubed divided by x. How many times does x go into x cubed? It goes into it x squared times. So I'm going to write the x squared in the x squared column. Let's work out the remainder exactly the same way. To work out the remainder on the left hand side, we did 2 times 3 and got a 6. So now I do x squared multiplied by, and I have to do all of x plus 2. So x squared times x is the x cubed, and x squared times 2 is 2x squared. Now, we subtracted 7 minus 6 to get a remainder of 1. We do exactly the same thing. We have to subtract x cubed plus 2x squared from the x cubed plus 3x squared. I like to put a bracket around this and a subtract sign because in my experience many students make mistakes here with the negative numbers. I know it sounds crazy that this is, complex mathematics at the high school level, but it's amazing how many people make mistakes with negative numbers, so do be careful with your negatives. X cubed minus x cubed is 0. I'm not going to write a 0 because we know it's 0. And 3x squared minus positive 2x squared is a 1x squared, and be careful there with the negative, so I like to put a bracket around that. Okay, let's go back to the left hand side. The next thing we do is bring down the 4. So it's exactly the same here. We bring down the minus 4x. Let's go back to the left hand side. Now I do 3 into 14. 3 into 14 goes 4 times. To find the remainder, 4 times 3 is 12, subtract, and I get a remainder of 2. Let's do the same on the right hand side. We do x's now. Here we did 3 into 14. So here we do x's into the highest degree there, x squared. And clearly x squared divided by x is a single x. So we have x. Again, to find the remainder, x times x plus 2, so multiply this x by x plus 2 gives me an x squared plus 2x. Put it in a bracket to help you subtract it. To find the remainder, x squared minus x squared again is 0, that should always happen. Minus 4x minus positive 2x is a minus 6x. Okay, now we have to bring down the 8. On the left hand side, 3 into 28 goes 9 times because 9 3s are 27, 9 3s are 27, and subtract, and we get a remainder of 1. Let's keep going on the right hand side. Bring down the 1, just the same. X into minus 6x, I should put a plus 1 there, apologies. x into minus 6x is minus 6. Let's multiply minus 6 by x plus 2 to find the remainder. So minus 6x minus 12. Put it in a bracket. Put a negative, because we're going to subtract to find the remainder, just like we did 28 minus 27. So minus 6x minus minus 6x is 0 again, which is what we want. And 1 minus minus 12 is 1 add 12, so we get a remainder of 13. So if we look at the left-hand side, we had originally 748 divided by 3. And we got the answer 249, and we got a remainder of 1. So we got 249 plus that remainder of 1 still has to be divided by 3, because obviously 3 doesn't go into 1. So that's one way we can write 748 divided by 3. 249 plus the remainder divided by the divisor. So here's what we call in polynomial division the quotient. This is the remainder. And this, 3, is the divisor. Now it's exactly the same with the algebra one. So if we look at x cubed plus 3x squared minus 4x plus 1 all over x plus 2, what we have here is the quotient, which is x squared plus x plus 6. That's what we got when we did the division, sorry, minus 6. Plus the remainder, which is 13 in this instance, divided by the divisor, which is x plus 2. And there we've rewritten the cubic divided by the linear function as a quadratic plus a rational function, which is really useful in many instances if you're doing integration or looking for where this has a oblique asymptote if you're sketching the graph. The important thing is in long division, this is called the quotient. This is the remainder. And this was the original divisor. Now if we look at the left-hand side again, there's another way we can write that. If we multiply everything by 3, we can get that our original number, 748, is 249 multiplied by 3 plus 1. Because when I multiply by 3, 1/3 changes to 1. We can do exactly the same on the right-hand side. So if we look here on the right-hand side, we can rewrite this equation as the original polynomial x cubed plus 3x squared minus 4x plus 1, I've multiplied both sides by x plus 2, equals the divisor x plus 2 multiplied by the quotient x squared plus x minus 6, and then plus the remainder, which in this case is 13. So what we have here is this is our original polynomial. This was our divisor. This is our quotient, which we can call q of x. And here's our remainder, which in this example is a number. I'll just put r for remainder. Okay, so once you've done the long division, there are two ways you can write your answer. You can write it as the top way here, which is the, I'll call A, which is the quotient plus the remainder divided by the divisor. And that's really useful if you're trying to sketch this graph here and you're trying to find the oblique asymptote, or if you're trying to integrate this function and you need to write it in partial fractions to help you. So if you're using calculus. The bottom form is also really important. I'll call that form B, because that's really useful if you're trying to factor a polynomial using the factor or the remainder theorem. So both forms are really important, and you should be comfortable in writing your answer in both ways depending on what you want to use the answer for. One final thing which I hinted at the start of this video, which is really important, is that all of your columns need to be intact. Let's consider 1047 divided by 5. Now 1047 means I've got 1000, 0 hundreds, 4 tens, and 7 units. Now I know it sounds like we're going back to kind of like primary school, but that's really important. So when we're writing this in long division, I need a 1 in the thousands column, a 0 in the hundreds column, a 4 in the tens, and a 7 in the units. Because obviously when I do the division, I'm going to get some hundreds possibly. So I need a hundreds column. It would be completely wrong, wouldn't it, to do 5 into 147 and miss out this really important 0. So this would be completely wrong. So equally, when I'm doing x cubed minus 4x plus 1 over x minus 2, notice that I've got a constant term, I've got my x term, I'm missing an x squared term, and I've got an x cubed term. So when you do the long division on this, which I'll do in the next video, you must do x minus 2 into x cubed plus you must have an x squared column, because when you do the division, you're going to generate x squared. So you need an x squared column. So don't forget to put a plus 0x squared minus 4x plus 1. Thank you very much for watching this. In my next video, I'm going to do this x cubed minus 4x plus 1 over x minus 2. So if you want to watch that, that would be great. Have a lovely day, everyone. Thank you very much.